A single night of sleep generates a massive stream of electrical signals from your brain, heart, and lungs. These waveforms are a constant broadcast of your internal biology in action. Stanford researchers built an AI called SleepFM to decode these signals. By analyzing how these rhythms align with the long-term health outcomes of 65,000 patients, the model can identify the early signatures of over 130 diseases, predicting risks for dementia or heart failure years before the first physical symptoms appear. This monitor tracks everything from brainwaves to blood oxygen simultaneously. The sheer density of this multi-channel data makes it impossible for the human eye to catch every subtle pattern, and traditional models that only look at your age or BMI miss these deep physiological warnings entirely. For decades, our bodies have been signaling future health crises every night, but we lacked the processing power required to read the message. To build a translator for this data, Stanford Medicine trained SleepFM on 585,000 hours of clinical sleep recordings. The data comes from polysomnography, a test that uses a network of sensors to record the body's various systems as they interact throughout the night. SleepFM slices these continuous recordings into precise 5-second windows, treating each block as a word, stacking them to read the night like a sentence. This allows the AI to analyze the body's activity as a structured sequence, turning raw biological noise into readable syntax. By organizing these signals into a language, the model can find the hidden connections between your breathing, your heart, and your brain. The model learns these connections through leave-one-out contrastive learning, a training method that forces the AI to find relationships between different organs. Researchers hide one major biological signal, like the heart's ECG, while showing the AI the other recordings. The AI then reconstructs that missing signal by identifying how it should behave based on the specific patterns it sees in the brainwaves and breathing. This training revealed that the most significant predictor of disease is disharmony, when one bodily system begins acting out of sync with the others. In a healthy body, these systems follow a predictable rhythm. A major warning sign occurs when the brain is in a deep, restorative sleep state, but the heart displays a stressed or erratic pattern. Using this method, SleepFM achieves a C-index of 0.93 for predicting Parkinson's and 0.90 for both breast and prostate cancers. These scores indicate the model outperforms traditional screenings that rely only on demographics by up to 17%. Ultimately, our future health is often determined by the breakdown of this hidden coordination across our complex biological systems. While SleepFM currently requires data from specialized sleep labs and operates as a black box where specific patterns are difficult to visualize, the technology is moving toward the home. Future versions of this AI will likely integrate with consumer smartwatches, providing an annual sleep health report that flags subtle deviations in your internal rhythms for early medical intervention. You can begin stabilizing your biological synchronization tonight without waiting for advanced AI. A strict, consistent bedtime is the most effective way to anchor your circadian rhythms and keep your internal systems aligned. Current wearables can track your baseline resting heart rate and blood oxygen. Establishing these baselines allows you to identify and report persistent abnormalities to your doctor before they escalate. Avoiding alcohol and heavy meals late at night prevents your cardiovascular and respiratory systems from being forced into high-activity states while your brain is attempting to rest. SleepFM works by analyzing 5-second windows of activity to spot system disharmony. You can support that same harmony by maintaining a consistent sleep environment and monitoring your baseline metrics. Sleep is a diagnostic window into your longevity.